Now, I was reading an interesting article by Kelly Crow of the CBC, and it was titled Cool Science, but Is It News? And she really does a great job of highlighting the interesting relationship between the media and the science community, and some of the interests that sometimes lie between them. Now, what she was using to illustrate her point was a small research paper, maybe a big research paper, that was being published in Cell magazine, which is an enormously popular publication, and it was about a group of Canadian researchers who had found a molecule that could be used to fight against cancer. Interesting news, but is it news, I guess, was the question she was asking. And what she highlighted was the fact that this experiment wasn't really that far along with the end goal of a treatment. That is to say, it was just an interesting discovery. It wasn't necessarily being used to treat anything at this moment. And she used it to highlight the fact that a lot of times science is presented in the media as something it's not, as though it's some sort of great new treatment that's right around the corner and something's going to happen. Think to the dozens of stories I'm sure you've seen about exciting new treatments for heart disease or cancer. And more often than not, these treatments don't amount to a whole lot, or if they do, it's a very small contribution to existing treatments. And of course, I'm not about to say that that is a bad thing. Of course, it's a great thing. But reading some of these articles, you might wonder, like, why are these journalists misrepresenting the science? And I think some of the blame actually lies with journalists who need to temper their expectations a little bit. But there's also the problem of PR departments at universities or hospitals or what have you. And what they do is they promote these scientific findings. They get it out there. They flood the boxes of science journalists and they say, hey, check out our new exciting whatever. It's about to be published in a major publication. You guys might want to pick up on this too. And sometimes it works. Sometimes the story gets traction and it's everywhere. But why are they doing this? The obvious answer is funding. They need funding for this research, so they need to make it look like even something that's in the infancy of its work can somehow be turned into a treatment later on, which will make companies lots and lots of money. Which is a little depressing, except for the fact that they are working towards treating illnesses, so I'm not too upset about them trying to game the system like that. But nonetheless, it is dishonest, and it does misinform the public. Now, what's important to realize is that you don't necessarily have to be misinformed. A good piece of science journalism, assuming you can find it, will at least give you an idea of where a certain treatment is in terms of its development. Well, let's look at a treatment that's actually very well developed, laser eye surgery. It's pretty much established. There's a robust amount of evidence for it and how it works, and it works in a variety of different ways. But its roots actually go way back. Some of the theories go back over 100 years on how light works with the eye and how vision impairments work. But the very first examples of surgery being performed to correct eye deficiency, so to speak, that will later lead on to laser eye surgery were done in the 1970s by Dr. Fyodorov in Russia, although it was the Soviet Union at the time. And a lot of that treatment, he basically was just cutting open eyes, which is totally gross, but that is what he was doing. But this actually influenced the development of the excimer laser, which happened in the late 80s, 1987 to be exact. And the very first person treated with that laser was in Germany in 1988. This, of course, was an enormous discovery and went on to create the LASIK system. I'm sure you're all familiar with that. That entered clinical trials in 1991. And you may have noticed there's a bit of a progression here. It started off with these somewhat undeveloped surgeries to successful treatments to the clinical trials of the early 90s. And you can see how this treatment for vision correction progressed. And over the years, that surgery had been refined and fine-tuned, and it was expanded to deal with different laser, different issues with vision correction and how the lasers could be applied for that. And we now have an awesome laser eye surgery treatment, which, even though it's kind of old, it's over 30 years old now, or no, it's nearly 30 years old now, it still sounds like something out of the future, which is pretty cool. And we have to sort of realize that treatments have these timelines. They have to go down these steps. And for all the successes in the laser eye surgery department, there's stuff that didn't work out. There's things that were sort of thrown in the dustbin, so to speak. And when you're in that timeline, it's harder to know what will or will not work. So this practice of just reporting on anything that sounds like maybe it could be amazing is somewhat irresponsible by the media and also the science community to a degree, who present their findings with unrealistic expectations. And to illustrate this a little more, there was a very interesting bit of research, and I'll try to sort of look at this research, as I hope you do, a little more critically. And this one came from the Rambon Medical Center in Haifa, Israel. This was a really cool bit of research where they took skin cells from people who are suffering from heart conditions. They exposed them to a chemical cocktail, and they turned them into stem cells. And these stem cells were applied in a therapy session and were used to repair heart muscle cells, which is phenomenal. It's the first time it's been done with people who are sick. Stem cells have been created from healthy cells or from healthy people in the past, but the problem with those cells is that they are for the healthy people. To phrase that in a way, it's easier to create a therapy with stem cells that are taken from yourself, but you don't really need that therapy when you're already healthy. So if you can get those stem cells from someone who's sick, the therapy will be so much more effective. Also, as a side note, we should not confuse that with embryonic stem cells. Adult stem cells are from adults. I suppose it's self-evident in their names. Just wanted to point that out. And what's so interesting about this experiment is that it's an example of someone who has been successfully treated. Think back to the laser eye surgery example in 1988, Germany, where the excimer laser was used to correct someone's vision. It's kind of like that. But as the researchers in Israel point out, their treatment hasn't even reached the clinical trial phases yet. It's still a few years away from that. And then when it's in the clinical trials, it's going to have to go through another process to reach the treatment phase. So while this sounds like, or it could be reported as, an exciting new treatment for people with heart conditions, it's actually several years off, and it should temper excitement a little bit. Still, you should get a little bit excited, but not so excited that you don't lose sight of the fact that science is a very long game with very small incremental increases. So there's an upside to that, though. Science is speeding up. More people are doing it, and it's getting better. But remember, whenever you see that exciting new treatment in the paper, just think of it a little more critically and see how it's being applied. Is it in the petri dish? Is it being used on living organisms? Is it being applied to humans? Is it in the clinical phases? Or is a treatment even being getting ready? That, I think, would be news. But news after a 10-year development plan sadly doesn't always get the coverage it deserves. So I hope you keep that in mind when you're looking at those exciting medical treatments, and thanks for watching.